up, introduce yourself. The floor is yours.
Hi, can you all hear me?
I can hear you.
Right, let me try to share my, oops. Just a minute. This Zoom is not working to share screen. Okay.
I see your screen.
Okay, good. Right. So it's like, I think quite a coincidence, Brad and Bill talk about something related and to what I plan to talk today. And I think I will just jump in to address Brad's point of this authentication and sharing with the world. I mean, the rest of the world, because that's really the gist of what I want to talk about today on DJSON, which stands for decentralized JSON. Now, what it is basically, if I can just show you the screen here. All right. Right, you can actually download my PDF from the address. Let me see if I can open the chat now. Okay. All right, just resend the address for the PDF. Now on the screen, you see that now the definition of DJSON is really simple. It's just a JSON string that has a hash in it. Now, what's a hash or hash code or hash number? It's really based on I'm sure you know if you can have longer hashes, but for me, I actually chose to use this shorter version, 53 bits of Mantissa from the JavaScript floating point number. And now I found this out by accident, and I thought it's quite convenient because if I use 53 bits, then what happened is that I will be able to get a short string, something like this. Okay, yeah, like 12 characters. This is a string. Now, to explain the significance of this string, I will just jump into a kind of RSA or public key authentication system that I design, or should I say just copy from somewhere and just make some modification. Now, if you recall, most of the login system that we use, perhaps a centralized, which uses your email or phone number. But of course, if you are familiar with SSH, then you know that it uses RSA but of course, when you use SSH, you don't bother to remember the public key because it's just too long, so you just keep a copy on the computer. Now, so in this case, what we are doing is that if I click on the authenticate button, now it will have a public key string, which is like that long. Now, which is of course not practical for, to be used as an ID. So what I then do is that I just convert that into a 53-bit hash. Okay, I have this is actually a Phoscript, which is a version of fourth dialect that I use. anyway, I'll just go into detail for that later, but I'll just show you now. That long, very long public key string becomes this G4, LFB, and so on. All right, it's now 12 characters because if you convert 53-bit into this is encoded in 64-bit ASCII string. All right. Now, okay, just to explain to you what is this my hash. Okay. Now, also I'm actually touching on another question of what Brad raised earlier. What language do you use to program this whatever? Now, what you'll see here on the screen here, all right, is a Phoscript, it's a dialect of Forth, right? So this is the definition for authentication. Now, what it means is that it sends this string, these commands to the backend and get the result. So session is basically to get a session variable. And finally, this HB64 is actually a function to convert the public key into the 53-bit hash that you see on the screen just now. If I just do that again. So this thing go from the front end to the back end, and the back end and actually will calculate this. Now, what is happening here is that the front end is actually, of course, running on JavaScript. And then the back end is actually running on PHP. Okay, so if I can just show you, right, this one. Now, this is a sort of fourth command, right? I'm just following the fourth convention. So we push the string hello onto the stack and then execute this 53, then B64 functions. And then the final result is this. And what happened behind the scene was this. All right. If I just do this grep page 53 star PHP. Okay, you will see that this is actually mapped to this file. Okay, and if I just show you lib hash.php. Okay. Right. And so what it does is that it push the input to the stack and then call the CY to calculate the 53-bit hash function and then put the result back onto the hash. So if I just show you what this is, right? Now, so this is actually the PHP implementation of the JavaScript code that I have shown you earlier. Now, to show you, this is you can do very simple fourth style debugging. So if you just take away this command B64, then you see a very long integer, which is actually the hash number before it was converted to the 64-bit encoding. So if you want to see where the 64-bit encoding is, you just do this. Right. So in fact, you see various very different versions of that. Okay, and that in the lib hash that we see just now. Okay, that is B64. Right, and then again it mapped to this function. Okay, so basically it just return the string. So if I can just show you again here, yeah, that's what you do. Now, the significance of this is that the hash string is actually a very interesting data structure, in the sense that it has this what I call the, just a minute, if I can find, yeah, all right. It has this what I call the integer type preservation property, or the ring theory property. That means it's invariant on addition and multiplication. What it means is that if you add two strings together and then hash it, then the result of the hash is of course a string. Now, what that means is that you can do very interesting mathematics on it. So if we go back to this example here, right, for example, in this case, this is a JSON string that follow this format, okay? There is a timestamp, action, the current user ID, the previous message owner. Now, doc hash here refer to the previous document. So we are able to generate the hash for a document, and then we can include a new message. So when you add this thing all up, this whole JSON string, you can actually calculate another hash for it. So what that means is that it actually implements something very important for the web, okay, or I mean information system. That is the ownership of digital assets. Okay, in this case, all digital assets, meaning anything from document, photo, video, and so on, basically document. All document or any file can be reduced to a hash code. And if you associate that hash code with a user hash, then you have a string like this, and then you can actually create a hash on top of this hash string. All right, so that is basically the whole idea of decentralized JSON. Okay. I just checking, Kevin, how many more minutes do I have? Kevin? Hello?
Sorry, I was off making myself a cup of coffee. I think you could take another 12 or 15 minutes without any problem. Is that okay?
15 minutes.
Sure.
Oh, okay, yeah, no problem. 15 minutes. Yeah.
All right.
Now,
1-1-5, not
okay,
5-0.
thank you. All right. Now, so what we aim to do with this decentralized JSON is something quite ambitious, right? That is, if we go back to the beginning of this slide, is that we actually want to achieve what this Bitcoin and blockchain plan to achieve. All right. Because if you actually, I mean, if any one of you have gone through, I mean, trying to study what Bitcoin and blockchain is, you probably find that there are actually too much documentation, and I mean, that was my experience, and I couldn't actually find the answer to what is actually behind until I sort of discover decentralized JSON by accident. And in a way, what I want to claim here is that, of course, it remains to be proven, and then the proof is actually quite interesting, and which I will explain later. That decentralized JSON is actually able to achieve what blockchain aims to do without the blockchain. Now, that is actually a very important hypothesis, because as you know, all this blockchain implementation has actually it has taken up a long time for them to develop since 2009, when Bitcoin was launched, and too much, they are now costing trillions of dollars to implement. Now, so if we found another way to, achieve what they want to achieve, that is basically, I have summarized it as the ownership of digital asset. Okay, basically what blockchain and Bitcoin wants to achieve is ownership of digital asset. If that can be done with this decentralized JSON, then obviously, there are lots of things that we can achieve. So I'll just go through this second part of this talk now. That is on the application of this decentralized JSON. Now, before I move on, maybe I can take a few questions if there's any urgent one, if you want to discuss whatever I have presented so far before I carry on the second part. Anyone? Okay. Now, I'll just carry on with the second part. So, what I have tried to, what I'm going to present in the second part here is, I'm trying to introduce this I2P, okay, Invisible Internet project. Now, this is actually a very old project that started in 2003. And some people like myself, we believe that this is actually the precursor to Bitcoin, because it seems to have all the algorithms that Bitcoin needs before Bitcoin was launched. And they are actually very low profile in the sense that, even if you try to go to Reddit, there are like maybe 30,000 members, which is not a lot. But it's actually very powerful because it allows you to bypass the domain name system. So what it means is that if more people, let's say 1 million user, now we are not sure how many users that I2P has globally today, because they are not like coordinated at the moment. So my proposal is that we can actually use decentralized JSON with this hash ID to coordinate different people running the I2P host. So then we can actually set up an internet that does not need a domain name system. Because if you think about it, if you try to, of course, it doesn't cost much to, to set up a host or whatever, to pay your cloud provider. But these cloud services, they have actually become like monopoly business. Nobody else can sort of enter this market anymore, unless perhaps maybe, if we actually get a lot of people setting up I2P and then we create our own internet. Now that may sound like something quite ambitious, but it may be something interesting to try out, because it really costs nothing to try on this idea. Okay, now you can find some of these videos on my YouTube channel, and this is actually a tutorial on how to set up I2P on the mobile phone. Now, this part is about the explanation on the architecture of I2P. Now, how this relate to our topic today is that what I'm trying to explain to you today here is that you can use all this technology now, today, for free, and set up your own node and share whatever your work with the rest of the world. All right, so this is just some configuration for the Firefox proxy that uses the port 4444 for I2P. Okay, this is the configuration. If you try to run it, then you will have this menu to show you, just to give you some confidence, so that you know how it looks like if you want to set it up. Okay. Now, the next part here is about how we redirect the traffic from the internet into I2P. Now, obviously, the I2P address is actually, it looks like this. This is actually a hash number by itself, all right? And so what you need to do is that, okay, this is what I do. On my GitHub page, I put in a redirection function, okay, that says like this, window.location, and the button that you see in the previous screen here, okay, any of this button will point to these addresses. So it's just a trick to redirect from the mainstream internet to I2P addresses. Okay, so now this part is about how to generate the hash code and the hash contract. So if I can just go through this quickly so that you can have an idea of what a hash contract and hash code is all about. So as you can see, the hash contract, now try to imagine the decentralized JSON that you saw just now as a compact version of this screen. So in this screen, you can enter your contract on this top right.
We can't actually see your screen.
You can't see the screen?
Yeah. Are you still sharing?
Are you? Hold on.
I see a screen that says AHD 27 April 0148 at the top.
Hold on.
Oh, I see the screen. Omni Web, Omni Contract.
Yeah.
Yeah, Omni
Same as
Star Web,
me.
Omni Star Contract, right?
Yes, I see it.
Okay, yeah, somebody saw
I
that.
see Omni Web, Omni Contract too.
Okay, good. Now, what is it here is that this is actually a demonstration of how you convert a contract into a hash. Now, you can put in any text in the contract. In this case, it says Brian will transfer some money, all right? But what we can do is that we can change this, right? Like for example, I can say Liang grants Bill the right to use Phoscript library from, let's say, April 2025 to May 2026, something like that. Now, then if you press this button, then you see this hash is being generated. So this hash is actually a direct conversion from here, from this. Okay, and then after that, you will be able to enter the user hash. Okay, for example, now this user hash is just a placeholder. It doesn't have a proper value. Now, if I just go down this page, right, and I press this button. Okay, so what it does is that it actually takes this part of this public key and generate the hash for the user. Okay, the same thing we can do with another party. So first we need to do generate a new key and then press this button to generate the hash of the public key. Now we have what we call the triplets. That is the hash of the contract and hash of the users. Now, when you have all these three, you can generate the root hash. Now, this root hash will represent your contract together. It sort of is implied, like who are the owner or signatories of this contract. Now, this is a very simplified version in that it does not have any other witnesses in this. Can I check with Kevin how many more minutes do I have still? Kevin?
How about 2 more minutes? Can you wrap it up? 2 or 3 more minutes?
Okay, 2 more minutes to wrap it up. All right. Now, so what I want to conclude here, okay. So what I want to conclude here is that this decentralized JSON format is really convenient for any kind of data structure sharing. And we can actually share, create our own sort of decentralized web that is separated from those already built out by companies like Microsoft and Google. All right, so it sounds like an ambitious project, but it is something, doable, I believe, because now we have found out all the simple steps. It's just like ants moving whatever building material to build their nest, really, if that is the kind of analogy that I can use. So I think I will finish my presentation here, and you can download the PDF. And of course, I will do the presentation again on more specific topics in the future. Yeah, thank you very much. Yeah, by the way, I just want to say that these are some. I'll just show you one screen that shows the kind of a forth-like commands that I use to build all this. All right, so it is contained in a file. Okay. Yep. So this is how it looks like. All these colon definitions, right, is safe in JSON string, of course, right? And of course, some of these make sense to you, some of them does not. Like Duke, of course, you know what it is, and most of the others are related to the native implementation. Or the host library, meaning it's either JavaScript or PHP. But the advantage of Phoscript is that it can be ported to like Android and even any other programming language very easily. And I think I will leave that to the another future presentation. Thank you very much.
What's the biggest barrier to having an alternative web? Is it the DNS? Is it that most computers are client instead of servers? Or because computers at home can't really be servers because of the ISP setup?
Well, I guess really I mean, if you want a sort of a conspiracy theory answer from me, which I think is most plausible, it's just a lack of promotion. You know, just like fourth, right? I mean, we all know that is very powerful, but somehow we don't actually get the mainstream channel to listen to us. So I think that the same thing happens to I2P as well. But of course, one of the hurdle that I2P face is that they have not created a data structure to coordinate themselves, right? Which is why I propose, using decentralized JSON as the method. Meaning to say that, okay, if I can just go back to the screen all right, this one. Okay. You see, if I set up a I2P node, right, I can create a decentralized JSON, something like this. I can say that you may use my node for web traffic or web server. You may run, let's say, 100 megabyte or 1 gig of space from my server. Now, this offer that I just said is actually a contract. Now, so at the moment, there was this the cryptocurrency of the blockchain people. They were trying to implement smart contract, okay, in a very, very complicated way. Now, obviously, I believe decentralized JSON is actually doing the same, but much more simplified. And yeah, so that's my answer to your question. Thank you.
All right, let's thank Liang, and we need to
Liang,
move on
can you
now.
put your,
You want to
you say
unshare?
code channel, if you could put it in the chat.
Liang,
Hello? Can you hear me?
Liang, can you respond to Joseph? Hi, Onet.
Hi.
All right. Well, Joseph, if you don't hear from Liang or want to communicate it with him further, I can facilitate that via email. Let's move
Sounds
on
good.
now. Onet, introduce yourself and present your talk. But first, Brad, let's reach an understanding as to what the deal is with the recorder. Nominally, we record until noon, and that's the end of the actual formal, use the word formal loosely, meeting. Onet wants to go a little longer. Brad has said that he's willing to go at least a bit longer. Hello, Brad.
Yeah, maybe like a half hour longer or something. See how see where we're at that point.
All right. I have a hard stop at noon, so I'll be leaving at that time. And Brad and Onet will work the rest out between them. All right, on with the show, Brad. Thank you. Onet, you're on.
Thank you, Kevin. I'm gonna connect on another computer, and because
I
sorry,
muted.
I thought.